All right, so today I just want to break down one part of the mixed numbers set of problems, and that is mixed numbers times fractions. We've done mixed numbers times wholes and mixed numbers times mixed numbers. So this actually isn't anything different than what we're already doing when we multiply mixed numbers times mixed numbers. Because in those problems, we always end up having to take a part of our group, like 1 1/4 groups of 2 1/5. We end up having to take that quarter of a group. Well, that's all we're doing now, because all we have is part of a group to begin with. So Ms. Shivik had 2 1/4 bags of M&Ms and gave her students 3/5 of all the M&Ms. How many bags did they get? So I'm giving you part of a group of something that I have. So I'm asking you to find 3/5 of 2 1/4. So let's do a quick estimate. 3/5 is not too far off of half, so I want a half of something that's just bigger than 2. So my answer should be just a little bit bigger than 1. So let's say probably around 1 1/4. So we're going to be looking for an answer that's around 1 1/4. So let's see what happens if I do my model. I want 3/5 of 2 1/4. So if I want 3/5 of 2 1/4, I need to start by drawing 2 1/4. Then I can take 3/5 of it. So here is 1, 2, and then I need my quarter over here. So in this instance, I'm actually going to black out the parts that I don't have. So everything I do have, the 2 1/4, is white. And just to kind of make things consistent, I'm going to split everything into fourths. So I remember that the part that I'm working right now is with fourths. So I need to take 3/5 of this. Well, when we took 3/5 of pans of brownies, right, what did we need to do? Right now we have 1, 2, 3, 4, 5, 6, 7, 8, 9 quarters. And that's not really easy to split into fifths. 9's not easily divisible by 5. So what we do in that case, if you remember, is that we go across. We're going to split it into fifths this way. So we're going to split each one of these into fifths going across. All right, so now if I need 3/5 of this, I can just take the top 3 rows of each box. So there's 3 out of my 5 rows here. Three out of my 5 rows here. Remember, I'm only dealing with the white part because that's the part I have. So 3 out of the 5 rows there. So what does this actually end up being? Ooh, cool zoom function, huh? So here I have got 12 out of a whole of 20 shaded. Same thing here. I've got 12 out of a whole of 20, and here I have 3 out of 20. Well, what does 12 20ths and 12 20ths and 3 20ths get me? 12 and 12 is 24, 3 is 27 20ths, or 1 and 7 20ths, which works pretty well with our 1 1/4 estimate, because this 1 and 10 20ths would be 1 1/2, so we're under that, so we're pretty close to 1 1/4. So what about mathematically? What if I want to do this without the model? Well, we have 3/5 times 2 1/4. So we need numerators and denominators if we want to use our traditional algorithm for multiplying, which means we need to take our 2 1/4 and change it into an improper fraction. So 2, if we're dealing with fourths, 2 would be 8/4, because 8 divided by 4 is 2, plus another fourth would be 9/4. Let's do a quick cross check to see if we can do any pre-simplifying. 9 and 5 have a GCF of 1, so nothing there. And 3 and 4 have a GCF of 1, so nothing there. But if we go ahead and multiply, 3 times 9 is 27, 5 times 4 is 20. We get 1 and 7 20ths. So we get a nice match. Checkamundo, happy days.